Hi and welcome back to Gaffy's Grinds. This is video 10 in our series on particles. Today we're going to be discussing the separation of mixtures. So in our last video we learned about mixtures and what a mixture is. So quick reminder just before we start the video is that if you guys have anything that's going to distract you, like if you have your phone on you, you should turn it off or put it in another room. And if you have any other tabs open on your computer, you should close them now. Also, when I ask you to do any exercise or questions, you should do them. As I always say, I can't make you do them, but you're not going to learn as much if you don't. So you have to try, put pen to paper and have a go at doing the questions. Okay, in our previous video, we talked about making a mixture. So we'll take an example. Here I have a container. Actually, sorry, I'm not going to draw it like that. I'm going to draw a container that we use in science. It's a glass container and we call it a beaker. Now in our beaker, we are going to add some water. And to the water, we are going to add some sand. So this here is a pile of sand. Sand. Okay, we're going to add it to the sand to the water. And what we're going to see is that the sand is just going to collect down the bottom. So we say the sand settles to the bottom. This is because the sand does not dissolve when it mixes with the water. So the sand settles to the bottom. It's because the sand does not dissolve when we mix it with the water. So what word could we use to describe the sand if it does not dissolve with the water? On 3, say your answer to the screen. 1, 2, 3. I'm hoping that you said the sand is insoluble. So the sand is insoluble. So we've got a mixture now of sand and water. Okay, why is this a mixture? So I'm looking here for a perfect definition of a mixture. And you guys should know this from the previous lesson. What is a mixture? So on 3, perfect definition, please. 1, 2, 3. And you know what? Actually, do you know, a better idea is you're going to commit here. You're actually going to pause the video and write down what you think the definition for a mixture is. Okay, because this is a really important one. So pause the video now and write down the definition for mixture. Okay, so you should only be watching the video if you've tried to write down the definition of mixture. We're going to check now, see if you guys have it right. So a mixture is where we have different substances together. So we put different substances together. Okay, I'm going to highlight that in blue. And here we have different substances together. Okay, that's not the full definition though, different substances together that are not chemically combined. So if you have different substances which are together and are not chemically combined, then you have a mixture. Sorry, that should say combined. All right, so check your definition now, and if you don't have it right, make a correction now. Pause the video, make the correction. Okay, good. All right, now we have different substances which are not chemically combined. So the sand and the water do not chemically combine. They do not make a new substance. This means that it can be quite easily separated and we can get back the sand and the water. And generally, when you have stuff which you've mixed together and they haven't made a new substance, they haven't chemically combined, it can be quite easy to separate. So how do we go about doing this? Well, in this particular step, to separate an insoluble substance from a liquid, we can use a process called filtration. Now for filtration, we're going to need the following equipment. We're going to need a conical flask, which is a cone-shaped flask, conical flask. We're going to need a funnel, which we can draw like this. This is a funnel. And we're going to need, inside the funnel, a special piece of paper called a filter paper. Now we would have done this in class. You guys, if you're watching from another school, you definitely should have done this experiment with your teacher. So you remember a filter paper, it's kind of like a coffee filter paper. A lot of students would recognize it as like, a lot of kids would always say to me, oh, it looks like a coffee filter paper. Okay, so I'm hoping that you either have seen filter paper before or you've seen a coffee filter. Okay, so we're then going to take our mixture of sand and water, what's in this beaker, and we're going to pour it into the middle of the filter paper. Okay, now what's going to happen here? Well, obviously, the mixture is going to flow into the filter paper. And the question is, well, how does the filter paper separate the sand from the water? Well, if we were to zoom in, have a look at the filter paper, what we would see is this here is the funnel, the side, the plastic bit of the funnel at a slope going down, and inside is the filter paper. So when we zoom in on it, we would see that the paper actually has these little holes in it. Okay, so I'm hoping you're looking at these little holes in the paper, these little gaps. Now, the water particles I'm going to draw in blue. And the water particles are small, so I'm drawing them just as little dots like this. And when we pour the water in, these particles can go through the holes. They fit through the holes because they're small. So the water particles can fit through the hole and they flow down into the conical flask. So over here, look what I'm doing. I'm drawing the water which has passed through filter paper. So this is the water which has passed through the filter paper. Now, an insoluble substance, a substance which is not dissolved. If it is not dissolved, its particles will not have been broken up and mixed with the water particles. So the sand particles will still be in large groups. So this is a grain of sand, if you like, and it's made of many sand particles. This is a grain of sand, and it has not dissolved. Oh, sorry about the spelling there. This is a grain of sand, and is made of quite a few sand particles. And because it does not dissolve, this group of particles does not break up. So if something dissolved, these particles would separate and spread out in the water. But because that hasn't happened, they're still in big lumps. And as you can see, this is going to be too big to fit through the filter paper. So it gets stuck in the filter paper. And what happens is these particles collect over here in the filter, the top of the filter. So that's what happens to an insoluble substance. Now, the substances which do not pass through the filter paper, so these substances up here, they get the name, the residue. And residue, that word just means kind of anything that ever gets left behind. So if you, even if you make a mess on a table after you've had your dinner, if you leave behind bits of food, that would be residue that gets left on the food. That would be the proper word for it because it got left behind. So anything which gets left behind is a residue. So this gets left behind in the filter paper and it's called the residue. The substance which has passed through the filter, it has been filtered. This will be this liquid down here. We call this the filtrate. This is the filtrate. Now again, why does the filtrate pass through the filter paper? It's because the particles are small enough over here. As you can see, the particles are small enough to fit through the filter paper holds. But the insoluble substances in these big grains are too big to fit through filter paper. The question, and the one thing that a lot of students always are never quite sure of then, is what happens if we have, example, sand, not instead of sand and water, sorry, we don't have sand, we have water, and we take, instead of sand, I'm going to draw this in pink here, we have a sample of salt, and we mix the salt in with the water. Well, what's going to happen to it? Well, it doesn't settle at the bottom like the sand. Instead, we say that it dissolves. And when it dissolves, the particles that it was made of, remember salt is a solid, the particles get pulled apart. Okay, so they start to separate and they go, basically, the water particles pull the salt particles apart, and the salt particles start to spread out amongst the water particles. Of course, there are water particles here as well, and I'm not drawn. So these are the salt particles that get pulled apart. Now, if we go to filter these, what happens is, for any of the particles which have dissolved, you have your filter funnel, and then you have your filter paper, which I'm drawing again over here. And when we pour our mixture in, obviously, the water particles, again, are small enough to fit through the filter paper. So they all flow through the filter paper. And this time, because the salt particles have been pulled apart, so because these salt particles have been pulled apart, as shown here, now these are small enough to fit through the filter paper. So that means filtration does not work for dissolved particles. So if a substance dissolves, or you might have a substance where some of it dissolves, but not all of it. So some of the salt, you might put too much salt in. So if I put, say this was 20 grams, and if I put in 100 grams, maybe only 20 dissolved and the other 80 did not. The other 80 settled at the bottom like this. It did not dissolve. The particles did not split apart. Well, only the particles which split apart are going to go through the filter paper. The rest of the salt here that's sitting on the bottom that's not dissolved is still in big pieces like this, and it won't fit through. So this would then be the undissolved salt still in its bigger pieces, and this would not fit through. Okay, that's pretty much it. Okay, remember the different equipment. Okay, so if you want to, this is a good diagram to have. The diagram here of the filter setup. Okay, so how to do a filtration. Might be a good idea to stop the video and label it. Stop the video and draw that diagram and label it. And maybe even the likes of that diagram there is a good one to have to help you keep in your memory how the filtration actually works. Okay, so if you want to pause the video and draw them two diagrams now. Okay, well done. If you have done that and you've paused the video and you have drawn those and you have labeled them, again, they are nice diagrams to have. Now, I'm going to give you some tasks to do now. And what I want you to do is I want you to do them without looking at any of the stuff that you've just taken down, please. Okay, so try and either, if you've got down the same page, cover it over with a book or change the page. Okay, so the first task that I want you to do is I want you to write out this paragraph here, and obviously I want you to write it, the full paragraph out, but I want you to fill in the blanks. So pause the video and do that now. Okay, so you should only be watching if you have written out that full paragraph and you've tried your best to fill in the blanks. The answers are coming up now. Again, there's no point in watching this and just waiting for me to give you the answers. You have to try and think hard and really commit to having a go yourself. Okay, so here are the answers. So pause the video and make any corrections to your answers now. And really well done, guys, if you got that right. It's really going to improve your scientific writing by practicing that there now, okay? By practicing writing good, coherent sentences in paragraphs. It's really good for your science writing. Okay, got some questions for you to think about now. Again, like I said, it's really important that you think hard about these questions and you do your absolute best to answer them. Do not leave them blank. Have a go. If it's wrong, no problem, we can fix it, but you have to have a go. Pause the video and try to do the questions now, please. Okay, so answers are coming up now. Okay, I think there's one of them I'm going to have to actually draw for you. It's 3E. So I'm going to have to draw that. Explain why a student could use a filter paper to separate a mixture of rice and water. Well, that is because the student could separate a mixture of rice and water with a filter paper because rice does not dissolve and therefore it cannot get through the holes in the filter paper. So the rice is too big, won't fit through the filter paper, and it doesn't dissolve. Explain why a student could not use a filter paper to separate a solution of sugar and water. Well, the key here is that it is a solution. And if it's a solution, that means the sugar is dissolved. Okay, so the student could not use the filter paper to separate a solution of sugar and water because the sugar is dissolved. That's the key bit there. And I'm checking my question again to make sure I've answered what they're asking. Explain why a student could not use your filter paper to separate a solution of sugar and water. Well, I'm talking about the sugar being dissolved. When the sugar dissolves, its particles separate and mix with the water particles, which allows them to fit through the holes in the filter paper. So I've really explained there why making when something dissolves, that means that then the particles can fit through the filter paper. Okay, so you see, it's really important to have a high quality answer. Sorry. Right. Back to question 3 now. When a student adds 30 grams of sand to 100 grams of water, the mixture has a mass of 130 grams. The student filters the mixture. What is the residue? Well, that would be the sand. That's the bit that didn't go through the filter paper. What is the mass of the residue? Well, we started with 30 grams of sand. None of that sand is going to fit through the filter, so we should have 30 grams of residue. So well done if you got that right, 30 grams of residue. What is the filtrate? Well, this is the thing that goes through the filter paper, so this will be the water. And what is the mass of the filtrate? Well, there's 100 grams of water at the start, and there should still be 100 grams of water at the end. Remember, we're not creating or destroying any matter or any particles, so should all be there at the end. Draw a diagram of the residue and the filtrate. Okay, so a particle diagram of the residue and the filtrate. So this is 3E here, 3E. Oh, that's a bit thick now. Right, so a particle diagram. So the residue is a solid. Now, I am going to draw in the filter paper, just because that's where it would be. So I'm drawing all the particles packed tightly together, no spaces between them. They've collected in the filter paper. This is the residue, and it's a solid. And of the filtrate then, I will draw in blue. The filtrate will be in the conical flask. Sorry, I should draw this as a cone-shaped flask. So it will be in a conical flask like this, and we have particles which are touching but not arranged in a regular pattern. Okay, so that is filtrate, and it is a liquid. So particle diagram for a solid, which is the residue, particle diagram for a liquid is the filtrate. Question 4, a student dissolves salt in water and passes it through the filter paper. Will any salt be found in the filter paper? Explain your answer. No salt will be found in the filter paper because the dissolved salt is able to pass through the holes with the water. So you won't find any salt in the filter paper. Question 5 was quite tricky, so well done if you got these right. Okay, so this is really expecting you to apply your knowledge. A student adds 50 grams of salt to 100 grams of water, but only 20 grams of the salt dissolves. The student then filters the salty water. What mass of salt did not dissolve? Okay, well that should be pretty easy. If 20 grams dissolved and you put 50 grams in, then the rest did not dissolve. So that's 50 take away 20. Okay, so it would be 50 grams take away 20 grams equals 30 grams. So there you see it. In B, 30 grams did not dissolve. C, what will the mass of the residue be? Oh, sorry, I never answered B. Why can the salt be separated by filtration? The salt can be separated by filtration. Sorry, what did it say, student? Why can the salt be separated by filtration? Well, because some of the salt didn't dissolve, 30 grams of the salt didn't dissolve, it can be separated by filtration because it has not dissolved, okay? So this is it here, because it is not dissolved and the particles are still grouped together. So 30 grams of the salt is still grouped together, they are not dissolved and it can be filtered. The other 20 grams, which is dissolved, cannot be filtered. C, what will the mass of the residue be? Well, this is the bit that gets filtered out. So this is that 30 grams of insoluble salt. So 30 grams here is going to be the residue. Well done if you got that right. And the last bit, I think this was the hardest question. What will the mass of the filtrate be? The mass of the filtrate will be 120 grams. Where did I get that from? Well, it was the 100 grams of water plus the 20 grams of dissolved salt. Both of these things will be in the filtrate because they both pass through the filter. Okay, so 100 grams of water and 20 grams of salt. These two together make up the filtrate. Okay, the other 30 grams makes up the residue. Now that, if you wanted to check, am I right there? Well, we have 100 plus 20 plus 30. Altogether, that's 150 grams. Let's check the question and see how much we should have altogether. So question 5, we had 50 grams of salt and 100 grams of water. So altogether 150 grams, and I've accounted for everything here. So well done. If you got those right, guys, that is filtration, your first separating technique that we can use to separate mixtures. This is a physical method of separation. It does not affect any of the chemicals. It does not change any of the chemicals. It is just a physical separation. It just takes apart two separate parts of a mixture. Okay, so that's it, guys. I'll see you in the next one where we'll be discussing evaporation.